Let ABC be an equilateral triangle of side length 1. Let P be any point inside the triangle ABC. Find the sum of the distances from P to the sides of the triangle. Draw perpendicular PD, PE and PF, that is PD, PE and PF from point P on the three sides BC, AB and AC respectively. Let these be H1, H2 and H3. Join point P to the vertices A, B and C. Point P is connected or joined to the vertices A, B and C. Now A1, that is area of triangle BPC, that is this triangle, area is half base into height, that is half of BC multiplied by H1, which is half H1 because BC is equal to 1. Similarly, A2, that is area of APB, this triangle, the area A2 is equal to half base into height, that is half H2 into AB, which is half H2 because AB is equal to 1. Finally, A3, that is area of APC, area of this triangle, is half of base into height, that is half of AC multiplied by PF, or AC being 1 and PF being H3, it is half H3. Now area of ABC, A is equal to A1 plus A2 plus A3 because this whole triangle consists of three areas, this, this and this. Therefore, A is equal to A1 plus A2 plus A3, which is half multiplied by H1 plus H2 plus H3. Let us call it equation 1. From this equation, we see the following conclusion, that is, since area of ABC is constant, we realize that H1 plus H2 plus H3 is the same constant, and more importantly, this does not depend on the position of the point P within the triangle ABC. Before going any further, please like, subscribe, share and hit the bell so that you can be immediately notified for new uploads. It is completely free and only takes a few seconds, and you can always unsubscribe later. And if you subscribe and do all these things, that will encourage me to put up new videos for your information. Also, if you know about any interesting problem that you would like me to solve, please upload it in your comments. Without further ado, let's proceed with the rest of the video. Now, draw perpendicular AG from vertex A onto side BC of triangle ABC. Then AG is height of the triangle H. Therefore, area of triangle ABC is half multiplied by height multiplied by base of the triangle ABC, that is half h into BC, but BC is equal to 1. Therefore, area of the triangle is equal to half h. Let us call it equation 2. From equation 1 and equation 2, we get area is equal to half h, which is same as area is equal to half h1 plus h2 plus h3. Therefore, half h is equal to half h1 plus h2 plus h3. Therefore, h is equal to h1 plus h2 plus h3. Let us call it equation 3. Since triangle ABC is an equilateral triangle, G is the midpoint of BC. This point G is the midpoint of BC because AG is the perpendicular from the opposite vertex on BC. Now BG therefore is equal to half of BC, and BC is 1. Therefore BG is equal to half of 1, that is half. Now from this triangle ABG, which is a right triangle because this angle is 90 degree, we have AB square minus BG square is equal to AG square. Therefore, H is equal to AG is equal to square root of AB square minus BG square, that is square root of 1 minus 1 by 4, that is equal to square root of 3 divided by 2. Hence, from equation 3, h1 plus h2 plus h3 is equal to h, that is equal to square root of 3 divided by 2, and that is the answer. Thank you.